Good afternoon, everybody. My name is Samantha Charles. Welcome to the 5th webinar in our Talking Timber series. Today we cover sustainability of timber in the built environment. Firstly, thank you to Sawmilling South Africa for making this webinar possible, as well as our academic partners from the universities of Stellenbosch and Pretoria. Our thanks must also go to the Department of Trade, Industry and Competition, as well as the Demand Creation Group, which has been formed out of the Forestry Master Plan, which has a mandate to promote timber in various sectors. And one of these is the built environment. Just a few housekeeping points as people start filtering through the doors, as it were. Please put your questions through on the chat functionality that allows everybody to see your questions, and we'll be able to answer them either in the session on the chat function or during the Q&A a bit later. We'll have Professor Brunt Wessels from Stellenbosch University introducing our two experts shortly. And then obviously we'll have that Q&A session, and we will then close with a message from Dr. Skull Grobelaar from the University of Pretoria. The session will be recorded and it will be posted to the Sawmilling South Africa YouTube channel, and I will put that link in the chat. It'll take a day or so for us to get that up and ready. We have a diverse audience today, just under 200 people, from architects and engineers to colleagues in the timber processing and forestry space. And the main aim of today's session is to help you understand timber better, wood better, forests better, and to smash some of the myths that so often we have about forestry, trees, and wood production. You're all familiar with, I'm sure, the steel, concrete, bricks, and all the other non-wood building material, but there's something special about wood, and it's something that will be shared by Ben and Vernon this afternoon in the next 90 minutes. We have a long way to go in terms of getting timber into the same leagues as its counterparts, and this is one of the reasons why we host these webinars. Timber is exceptionally special. It's beautiful, it stores carbon, it's renewable, it's farmed just like we farm mealies and wheat. We farm trees, we plant them, we grow them, we harvest them, and we plant new ones. And there's a science behind it too, and that's why we have some experts with us today. Over to you, Brunt.
Afternoon, everyone. So our speakers today are from two different disciplines, but their work intersect on sustainability. So Prof. Ben Toit is a lecturer and researcher in silviculture at the Department of Forest and Wood Science, Stellenbosch University. Ben has authorship of more than 100 papers, book chapters, and technical research reports to date. He maintains active collaborative networks with forest researchers in Southern Africa, Europe, and South America. And he also acts as a consultant on nutritional, silvicultural, soil, and fire-related matters in forest ecosystems. And then Vernon Collis, he's a civil engineer and an architect at his own consultancy firm, Collis and Associates. His practice focuses on sustainable systems design for the built environment, and particularly in the shift from a hydrocarbon-dependent economy to an independent, renewable one. Timber is a key component in this transition. His work extends into the inclusion of the unemployed and unskilled using appropriate and intermediate technology. Vernon is also an adjunct professor at the University of Cape Town, civil engineering, and he has been in practice for 35 years and is based in Cape Town. So Ben and Vernon, a very warm welcome to you too. Ben, so if you can maybe start your presentation, please.
Thank you, Brunt. Let me just try to share the screen here. Right, that should come up any moment now. Please indicate if there would be any problems with the sound going forward. So thank you for this opportunity to talk, and the title of my talk is to see if timber production in South Africa is really sustainable. So I'll try to lay the foundation to show that it is indeed sustainable and that we can supply a decent resource that architects and contractors can use. So if we can go straight into it. I will talk about the forests of the world, particularly then the forests of South Africa, population, productivity issues of different forests, and make out a case for the need for plantation forests. And then I'll go to sustainability and certification as well as the environmental footprint of our planted forests, or plantations as they are known, and then draw a couple of conclusions. If we start off, the forests of the world, you can see that there's a very large group of forests. Let me just get this pen focused here. Up in the north, there's a very large group of boreal forests, and over here it's known as the taiga. And these forests grow in the extreme cold climates, mostly coniferous forests. So they are not extremely productive, but they cover a vast area of land on the planet. And then we have our tropical forests, the Amazon, the Congo Basin, West Africa here, Indonesia, etc. And they normally consist of dipterocarp trees, fairly fast growing by natural forest standards, but as we shall see, not all that fast if we don't manage them. If we then move on to southern Africa, maybe I should just point this out, we are very sparsely endowed with forests of a natural kind. These are the biomes we have in South Africa. And as you can see, we have a fair amount of plantation forestry that's been established in this fynbos biome over here. By the way, the purple is the only high forest that we have. And the green here is the savanna forests that we have, the dry bushveld. But a lot of forests, planted man-made forests, have been put into the fynbos here and along the eastern escarpment of the country into this grassland biome that you can see here. So most of our plantations are then planted into either the fynbos or grassland biome, not into the forest biome, for the very reason that the forest biome is so few and far between and it needs to be conserved. So these are the kinds of forests that we then get in South Africa. At the top here, you see the typical savanna. If it gets a bit denser than that, we will call it a bushveld or a woodland. But that's typically what it looks like. There's a grass component, there's a tree component. It's not a continuous cover forest. Over here in the middle, we have the high forests. This picture then taken near Knysna. And that shows you indigenous species in a complete canopy cover situation. And in the bottom here, you can see a typical pine plantation. Eucalypt plantations don't look all that different, established in a grassveld area in this case, but with very vast areas of grassland in the background here, in the middle ground, that have been left unplanted. Those are our so-called ecological corridors that I will speak about a little bit later. So you can see that these middle and bottom categories cover very small areas. It's only the woodlands that cover about 30 million hectares in South Africa. The closed canopy forests of the Southern Cape and the Eastern Escarpment, 500,000 hectares. Plantations, 1.3 million hectares. It's not a lot, but then this is really the bread basket, so to speak, of our industry. Let's call it the fiber basket. So on a world scale, we've got 0.06% of the land area has closed canopy forests and plantations. And the bulk of that, as you can see, is in woodland and savanna, which mostly supplies things like firewood and fuelwood in our context here. Then if we go to the forest productivity to serve human needs, as you all know, our population is increasing all the time. And let's just look at a couple of natural forests. I mean, if you start with a boreal forest, those very far northern forests, you know, much less than 1 cubic meter of wood is laid down per hectare per annum. If you go to the Tsitsikamma, that number comes a little bit closer to 1, but still a little bit short of 1. If you go to a place like the Amazon, which is the highest productivity, it's about 2 to 5 cubic meters of timber laid on all the trees collectively in 1 hectare in 1 year. If I now put that to you, that the average plantation productivity in South Africa, which is a fairly dry country by international standards, is 22 for eucalyptus and 15 for pines. You can clearly see that it's at least 3 times, and in some cases 10 times as productive as some of these temperate zone natural forests. So we really need the plantations. We need to grow a lot of timber in a very focused and high productivity way. Otherwise, we will need vast areas for it, but we would rather grow it fast on a few small areas, as we are currently doing. So what would be the reasons for very high plantation productivity? The first thing here is that most of the species came without their natural enemies. That helps a little bit, but it's not everything. Then we've gone and selected the most superior provenances of each species. For example, we would go to Mexico and select the best pines there, and go to Indonesia and Australia and select the best eucalyptus there. and then even breed them a little bit further in a genetic tree improvement program. And if we then deploy those trees, they grow quite fast because they're the cream of the crop. But not to forget that we farm quite intensively with trees by forest standards. So we do very intensive silviculture. We prepare the soil, fertilize it a little bit with very low level dosages, but nonetheless we fertilize, as most man-made forests, most indigenous forests are obviously not fertilized. And we match the right species to the right site and the right hybrid to the right site. And then we prune these things, we thin them out when necessary, and we do field load management and weed management and so on. So all in all, a fairly intensive silviculture that leads us to a fairly high productivity. And so I think now we need to talk about sustainability. We hear so much in the media about trees having a very negative impact on the environment, and a lot of people like to say a lot of negative things about trees in the popular press, often not substantiated by facts. So let's look at some of the facts around sustainability. When did the concept of sustainability start? There was a guy in Austria with the name of Karl von Karlowitz. Already in 1713, he introduced this concept of sustained yield. In other words, never to harvest more than what is possible for the forest to regrow in the same period of time. So if you have an annual harvest of X cubic meters of timber per hectare, then that amount of timber must be able to regrow again in that same year. And that made sure that we never depleted the growing stock. So these very firm sustained yield principle was already implemented in the 1700s. And quite correctly, it makes forestry the first sector in human society to discover and implement the concept of sustainability. Other people did this since the 1970s. So sorry to say this, but forestry did it long before it was cool. In South Africa, even in the early days, as far back as 1880, as you can see here, this French guy with the name of de Vasselot de Regnet was appointed as superintendent of forests. He graduated at the University of Nancy, and he made a very good attempt to manage the forests on a scientific basis and stop overexploitation. And these were his policies, as you can read them here. So again, in South Africa, we've come a long way in ensuring that our forests are not depleted or managed in a non-sustainable way. But we have broadened the concept even further from sustained yield to sustainable yield. And the idea there is really the triple bottom line, and that is shown here at the bottom. And the reason why it is done is because if you have improved silviculture, improved tree breeding, you may mask any site deterioration that is happening. Let's just say you're causing erosion in the soil or nutrient depletion, but you just plant a better genotype, you may be able to cover for yourself and not notice that the actual soil upon which your plantation depends is being degraded. So for that reason, we came up with this triple bottom line. We must maintain the environmental quality and the resource base on which it depends. So we cannot unsustainably harvest the forest, but we can also not deplete the soil, pollute the water sources, or mess up the biodiversity completely. We have to look out for all the environmental quality indicators. Secondly, we have to provide products and services for human needs so that we can enhance the quality of life. And thirdly, it must be economically sustainable and viable. If we meet that triple bottom line, we feel then we are truly sustainable and not just practicing sustained yield. What would make a plantation unsustainable? If we erode the soil, if we deplete nutrients in the soil or deplete the organic matter contents of the soil so that the biological processes can't happen anymore, if we have very bad environmental impacts, for example, soil compaction or something like that, if we deploy a very weak or inappropriate genetic base, we will open ourselves up to pests and disease attacks, as the next point shows. If we have very poor management, we will drop in productivity, and that will lead to the next point here, which is not economical performance or non-economical performance. And if we exploit people in the process of growing trees, of course, there will be no social justice or sharing of prosperity. And these things all should be avoided. So it's a couple of these myths that forestry is involved in these issues that I would like to dispel today with facts. And that's why I have started this title here, subtitle rather, to look at plantations and their environmental footprint. So let's just look at things at the landscape level. Several things have to be managed at the landscape level, and one of these would be water use and biodiversity. You cannot just mention that, manage that on a compartment level. You need to manage that on the whole landscape level. Let's look at a couple of results that were obtained with modeling plantation water use. Excuse me for a moment. That is stream flow reduction patterns caused by afforestation. What people did is they used this Acox felt type that was known at that time. Now we have Mucina's felt types as well nowadays, but in those days that was the only felt type known. So it was, let's say, Tomedo grassland type of felt type. They used different soil depths and different soil textures, looked at an area where the stand age is corresponding to the median stream flow reduction, because when a stand is young and you plant it, it uses only a little bit of water. When it gets mature, it uses more water. So they used the median, and they presumed 100% afforestation. Put it into this agrohydrological model, which takes care of all the water fluxes, the rainfall coming in, infiltration, evapotranspiration, runoff from the surface, etc., etc. And at the end of the day, they plotted the results like this. You can see here on the x-axis at the bottom, it's the mean annual precipitation, and here on the y-axis is the average stream flow reduction in every quaternary catchment. This stuff here in the circle is the winter rainfall zone, and I've plotted a little line through there to show the average. And the stuff represented by the red line would be the summer rainfall zone, and there is the stream flow reduction there. So you can see that it's about 80 millimeters where there's 1,000 millimeters of rainfall. So it's, in this case, it's as much as 8% reduction, but the bulk of the sites are located right in this area between about 650 and 850 millimeters of rainfall, because that's just the way the country is. We have very few places where there's very high rainfall here. So these guys are using about 4 to 5% water, whereas the winter rainfall sites here using about 3 to 4, in some cases 4.5% of the water. All in all, the national average is then the bulk of the forestry site is causing a stream flow reduction of between 3 and 8%. With, if you want an absolute single number, 4% is the national weighted average of the stream flow reduction. That's hardly a large number. What you hear in the media is sometimes things like the trees have guzzled up all the water and there's nothing left for anybody. That is absolutely untrue. So the other thing that a lot of people don't understand is that evapotranspiration and water use is much more dependent on what the atmosphere will accept than on the type of vegetation cover. Here is the stream flow reduction if we were to plant 100% of a catchment with forests, with planted forests. And you can see, for example, that this area around Lesotho will never be planted because it supplies into the Gauteng area here with the Katsi Dam and those kind of water works. This area here supplies the Pietermaritzburg-Durban corridor. So these things will never be forested 100% here around Lesotho. But that would be the stream flow reduction if we were to forest it. Here in the Mpumalanga escarpment area, we get some high stream flow reductions here in the vicinity of 100 to 120. But keep in mind there that the rainfall in some of these zones would be 1,200 up to 1,400 millimeters. And so again, it is not such a high loss because it has been seen that the higher the rainfall, the higher the usage by planted forests. Obviously, if there's more water, they will use more. But then there's so much to go around that there's usually plenty for downstream users as well. Another little piece of very good scientific research that you will never see in the media is the water use efficiency. This was done by Mark Gush and Peter Dye, two very respected scientists working at the time for the CSIR, and they looked at the grams of wood produced per liter of water transpired. And as you can see here in the right-hand side, we've got several indigenous species that they used as controls. And then all these solid bars over here are plantation species. Now, most of them, pines and eucalyptus, there's quite a variation depending on the provenance, but we usually choose obviously the ones that are more water use efficient in our tree breeding experiments. And so you can see some of these trees use water up to 2 or 3 times more efficiently than most of our indigenous species. So they put on more wood per liter of water transpired than any indigenous species tested to date. So we are getting more bang for our buck by planting these trees because we've selected them like that. We've selected the best provenances, and then we bred them even further to be highly water use efficient. There's no surprises here. Then what about biodiversity? Is forestry having a very negative impact on biodiversity? The first thing that is very important is that it has to be done at the landscape scale. And the way to do it is with these ecological corridors and ecological networks. In other words, leaving vast areas unplanted, as is shown here. Around this wetland, there's a big node of grassland. There's an afforested patch here. Then there's another corridor here in the foreground where animals can freely roam, and you can still conserve your biodiversity, even though inside the compartment, you've lost some biodiversity. But on a landscape scale, you've often stayed the same or even gained. Conservation officials that studied the forestry areas have concluded that these areas inside forest-owned land are refugia for threatened plant and animal species. So definitely because they are well managed and all sorts of poachers and other people who could negatively impact on the ecological quality of this landscape is being kept out. So where there's good management, there's good ecological consequences. About 33% of all forested land in South Africa is actually unplanted. In other words, it keeps the indigenous species. Here you can see some more examples. Around a stream corridor, here in the foreground and in the background, that area has been burnt to also provide niche sites for certain biodiversity areas. Here we've got animals roaming around on these ecological networks. And in some places, Mondi has even got elephants in the plantation. So these ecological networks that are linkages between areas of high conservation value are so well recognized that they are counted among 3 most notable in the world: the Pan-European Environmental Networks, the Greenways in China, and then the South African Timber Industry Environmental Networks, as you can see them here. So we are doing the right thing in terms of conserving biodiversity in forestry. What about invasiveness? And here is important that we look at 2 different issues. Invasive trees that were brought in to stabilize the drift sands at the top here. This has got nothing to do with forestry. This was a conservation operation. A lot of these Australian acacias were brought in that could fix atmospheric nitrogen and seed themselves. They have become a pest. But the good news is that with biological control, almost all of them have now been brought under control. With biocontrol, I mean they have imported pests and diseases that predate the seeds and attack these trees so that they don't spread so much seeds anymore. So slowly this battle is being won. What about the invasive species that we still use in forestry and agroforestry? There's a couple of them here. Give you some examples. Pinus pinaster, nobody's planting it near boundary lines anymore, again, to limit the spread of it. People are working very hard to breed sterile wattle at the moment, and so we can continue. There's a biocontrol for prosopis species. There's a biocontrol for these acacias. So we are making very great strides there. But the most important thing in my mind is what is shown in red here, is that people are moving away from pure species to interspecific hybrids because we can combine very favorable traits between different plants. If we make these interspecific hybrids, they are more drought resistant, they are more disease resistant, they are often have got better quality timber, as Brunt will tell you. And by doing so, we are creating a whole lot of growing stock that have very low reproduction potential, because if you plant them as a clone, if they do cross-pollinate each other, which they sometimes do, it's almost the same as self-pollination, because a single clone has got the same genetic material, and that means that they become very quickly inbred if you want to plant their own seeds. If you want a new hybrid, you actually got to go to the good populations, cross the right mother with the right father, and propagate that vegetatively again. So now humans are in control. They can't spread themselves anymore. So that is a really big deal in terms of combating invasiveness. And some of the species that were moderately invasive still have now been phased out mostly. For example, Pinus spatula. SAPI completely stopped planting Pinus spatula 3 years ago. They're only planting the Pinus spatula by Technomanii hybrid. And it grows much better, and it's not invasive. And so we can continue. There's several eucalyptus hybrids and so on. And of course, there's these biocontrol imports that also made a big difference. So then, without laboring that fact too much, let's just look at some effects at the site level. What about nutritional sustainability and soil conservation? I did quite a lot of work on this, looking at all the inputs and outputs into an ecosystem and then how the nutrients move around in the ecosystem, followed the nutrient fluxes, made a sum of everything coming in, everything going out, and then looking at this readily available pool to see if we plot the net loss as a fraction of the available pool, what will happen. And these are the numbers I got. So if we do very intensive management where we actually burn all the slash in a fairly warm fire after clear felling before we re-established, which is something that is really frowned upon nowadays, then we use a fair amount of nitrogen. But for all the other nutrients, we lose very little nutrients, not anything that we cannot very easily resupply with fertilizer. And so we are not losing sleep over this. But the main take-home message here is if we change our management to go just from slash burning to slash retention, suddenly most things are here very close to the 0 mark. So then there is not a big loss of nutrients over time. More importantly is that we have gone to many sites, 28 pine and 21 ukes to be precise, and we worked out this index of nutritional sustainability that I came up with, which is the net annual nutrient loss. That's the difference between that input and output fractions, divided by the nutrient pool, and in this case, it's the readily available nutrient pool. We've shown that the PINS value then comes up, and that P is, of course, the same as the P in pH. It's a negative logarithm. So if we get values of between 1.6 and 1.8, that means we are losing as little as 1/40th or 1/60th of the readily available nutrient pool. That's not much. And remember, that pool is constantly being replenished by weathering. So it's not something to worry about. Even if we do whole tree harvesting, we cannot get these systems to crash. We've got a couple of experiments that Stephen Dovey started at the ICFR, where we literally milk the nutrients off the site by doing very aggressive harvesting on an annual basis. And we could not get a single site to crash in terms of nutrient depletion. So if we manage it 10 times more intensively than we currently do, we still cannot crash it. I think you get the idea that we are not going to run out of nutrients anytime soon. The last thing, what about soil erosion? Soil erosion happens in 2 phases. First of all, you've got to detach the soil particles from each other, and that happens through the rain splash, tillage, or trampling or harvesting operations. And then you've got to transport it using wind, water, or rain splash. And then it can collect in these channels, rills, gullies, and eventually go into the river or in the ocean. Eventually. So let us just look at this very interesting work by Morgan in the UK, who did this work on various conservation practices, mostly in agriculture, to prevent both detachment and transport phases of erosion. And here we've got the D for detachment and the T for transport. And you can see all sorts of things that agricultural people do to protect their soil against erosion. But can you see here at the top, if you can cover the soil surface in the agricultural environment, it'll mean something like a mulch. You get a very good protection all through the board, from detachment and transport of all mechanisms. And as I say here, the forest floor layer covers the surface most of the time. Only time that it doesn't cover it is if you, as the manager, literally disturb it by either burning it or raking it up or doing something silly like that, which is not the status quo everywhere. It is just done in exceptional circumstances. So most of the time we have extremely good protection against erosion, much more than agricultural people would ever have. So they are pretty jealous of our situations. If we just look after our forest floor, erosion should look after itself. So in summary, can we really afford not to have plantations? We have more and more fiber and wood material needs in the world. We have a need for carbon sequestration, and we cannot just burn fossil fuels and use energy-intensive materials all the time. Some people will say we have big impacts in forestry, but I ask you, is the stream flow so bad? Well, actually it isn't. It's about 4% on average. Coupled to the fact that the plantation trees give us the biggest bang for our buck in terms of water use efficiency, I think we should continue with this situation. In the right place. Of course, we're not going to plant trees in a place where there's a water scarce environment, but in the right places where we do have water available, we can use it very efficiently with plantations. We're having a change to non-invasive species and hybrids, and that is a game changer for that particular point. So I don't think we are going to have that many problems going forward. We use very conservative amounts of nutrients and then, of course, very little erosion. So I think to sum up, there are very few impacts. We can hardly call them impacts. The major benefits that we can get from forests are listed here. And it goes from jobs, money, community upliftment, recreation and human well-being, climate change mitigation, and adaptation as well, erosion control, good urban interfaces. Everybody wants to go and walk or ride their bicycle or walk their dog under trees rather than in the open sunlight. We need renewable energy sources, and that forests can provide. Very good riparian zone management, again, because there is management present on these lands where forestry happens. You know, the people who manage the forest also manage the natural areas. As we've seen, we've got several biodiversity refugia on our plantation estates, and probably the most important one, carbon sequestration, which if we put it into structural timber and things like that, it prolongs the half-life of the time that carbon is sequestered, and that makes a very big difference in terms of bringing down carbon dioxide levels in the atmosphere. And I think lastly, you know, it's like sort of only supplies the air that we breathe from trees. So I don't think really there's a case to be made out not to have trees. And then to conclude that the scientific facts show us that trees can be grown sustainably. It's not quite true what the popular media sometimes tell you, that trees are so terrible and they guzzle up all the water and deplete the soil of nutrients. That's simply untruthful. People are managing forests with very strict sustainability criteria in mind. And we are training young foresters to uphold this tradition. But you guys, the architects, giving instructions to the contractors, you will do very well to use more timber from sustainably grown wood and wood products from South African plantations, because that will be very good for our country and very good for our environment. Thank you very much.
And thank you, Ben, for the introduction to this topic. I'm coming from a slightly different angle. I'm picking up from Ben, being a practicing engineer and architect in the industry. I'm going to try and tackle a different story, or build on that story, is the practicality of doing this. And what does it really mean? And what I understand from architects is a very difficult product to sometimes sell to your client. And we want to have a look at that. What are some of the basics? What is the toolkit that you should have on your desk to help you argue and to motivate for the material? So in doing that, I've divided the talk into 5 parts. Just a brief CO2 update of where we are, a materials overview, because we need to have a look at what materials are we using in the industry and how do we unpack all of the negative press that timber gets in South Africa, and how do we shift to a more bio-based materials, construction materials, and using SA-grown timber. I'll pick up from what Ben did. And then I'll just close with some case studies as myself, as in practice, what I've tested or where I've advised others to test different ways of what we can do with South African timber. So I want you to hold this lens at all times as a consultant, is that there are the 3 legs of environmental sustainability. I'm not talking about economic or social sustainability, but the 3 legs of environment sustainability are pollution, resource depletion, biodiversity reduction. So running into the new millennium, we need to remain cognizant of those three impacts on the planet at all times, and that any action we do mitigates or has as little negative effect. In fact, we're wanting to move towards a more positive effect on the environment. And quite simply, for architects and engineers, every time you write on your drawings, you write a specification, everything we do turns into a mini economy. It affects the economy, and how we specify will affect those three things. The big one on the topic is pollution, is carbon dioxide and methane in the atmosphere. But we mustn't lose sight of the other two, resource depletion and biodiversity reduction. And Ben covered that very succinctly in the previous talk. So this is a little picture, a graph. Part of our education, I think, as consultants. This is going back 600 million years of, it's a graph of 600 million years of the CO2 that was absorbed over this period. And we go back 500 million years ago, that's when life really started to kick in on the planet. And you can see CO2 was running at over 4,000 parts per million. The planet was hugely hot. And as life developed in the oceans, life pulled that carbon out of the atmosphere, right down to in 300 million years ago, that's the Carboniferous, and it did it in two ways. So all life pulled carbon out the atmosphere, but the biggest one was the life in the oceans, and the shallow seas were warm, they were teeming with life. They pulled out all the CO2, added it to calcium to form calcium carbonate, and 80% of the world's fossil carbon is stored in limestone. That's 80%, and the other 20% is in fossil fuels. Now, South Africa, we don't have a huge amount of limestone, but what we're doing at the moment is that we are digging out limestone and we fire it to make cement. So 60% of the CO2 that goes up in the production of cement is from the firing of limestone. It's fossil CO2. So that's why cement lime products, if you add lime to cement products, you're getting over 10% of the global carbon footprint, which is large. Interesting, animals made this product. So if you specify marble, because marble is comes from limestone, it's compressed and transformed, that you're actually using a fossil product. Now, as the graph goes along, you get to 200 million years. Well, there's an ice age of 300 million years. You chop along, and then dinosaurs. And then from about 140 million years ago, the broadleaf forests start to kick in around the planet, especially around the tropics. And then they kick in and they suck the carbon down from 100 million right down to today. And then you can see added today, just before today, there's a little turn up, and that's the Industrial Revolution. And the big question is, where do we go from the Industrial Revolution? Now, can you imagine that graph really follows what life has been doing to carbon over its time period. At the moment, all that limestone is locked in mountains. The next question is material overview. The debate of, materials can only come from two parts. Materials are either mined and processed, or they're grown and processed. So everything around you, in the room around you, whatever we build, it's either mined, dug out the ground and processed, or it's grown and processed. That's it. So that's where we are sitting at the moment. And as a designer, always ask yourself that question. What am I actually working, what am I using with, and where does this come from? No. Oopsie. Sorry, I've got lost here a bit. So this graph here, it's the graph of years at the bottom, 10-year period, and percentage of carbon dioxide in the atmosphere. So this is a graph of where we're going at the moment on the planet. The percentage of metals, mainly iron, and the percentage of cement. So the top dotted curve is iron and aluminium, those products, and cement below. That carbon is a combination of processing of all the materials, and obviously some of it's got the fossil CO2. But by 2040, we're not in a good place. At the moment, we're saying cement is roughly about 10%, and it's going to get to 30% by 2040. it's not, our population is going to go up to they say 9 billion, maybe just over 9 billion by 2040. But the problem is the growth of megacities, and Africa and Asia is the problem. So with these megacities, and at the moment, it's business as usual. 99% of buildings are still being made like they were in the last century. And the whole system of how we teach and do things from the last century prevails. And the philosophy of the last century was the planet has no limits. The new paradigm we're in is the planet has limits, and that's where the biomaterials come into being. So that's not a good graph. I have to add, there's a lot of new technologies coming. This all depends, and this is with what we know now. There's some remarkable technologies in carbon capture. There's some green energies coming out. We don't know where we are, but this is where we are now, and those curves are plotted on that assumption. Hopefully something can happen. Technology can come in, but this is where I think trees can do a huge part. Some figures say that trees can help up between 20 and 25% of reducing that curve. So as a designer, sitting at a desk, important to have these 5 materials under your belt. And if we have a look at it, we've got concrete, and this is a comparison of the kilograms of CO2 per ton of material. That's the metric. So if you have a look at that, the highest one there is aluminium. And I won't go into why aluminium is so high, but aluminium is massive. Then steel is down at 1500. We've got concrete at 850, and then clay bricks doesn't look too bad. And I put plantation at 0 if that timber that is cut and used is kept and we measure the carbon stored. Now, when you look at that, you think, okay, avoid aluminium, definitely steel. Let's see what we can do. Concrete, concrete's quite high. Let's build with clay bricks, plantation timber. In engineering, metrics tell the different story. And I'm going to swing the metrics, and I'm going to do it and say, we're going to have a look at these mined and processed materials. Those are the ones within the red block versus grown materials. And I just did an exercise on a simple single-story garage. It's made of bricks, clay bricks, plastered, metal roller shutter door for the garage, aluminium windows. Your standard little garage. And I've used just conventional materials we'd all do a garage. Now, if you measure the CO2 of these materials in use, the whole pie chart changes completely. 50% of that building, the CO2, is from the clay brick walls. 25% from cement products and 25% from metal products. So immediately that starts you to think, gets you to think. The overall carbon footprint of that little garage there is 7,500 kilograms of CO2, and that's 30 car trips from Cape Town to Lusaka in an old Toyota. So looking at that all of a sudden tells a different story. If that's timber frame, we can make major differences to that. So I'll leave you with that drawing and for you to think about that as we move on. So the idea is what we're facing is South Africa has a reinforced concrete masonry steel culture. I don't have any problem with those materials. I love them. I love using them. But right now, where we are on the planet, given that the construction industry contributes about 40% to the total global footprint, I think we've got to do something. And given the new IPCC reports, which were shocking, that it seems like everybody, we've got a duty to sharpen our pencil and think twice and adopt and adapt to how we speak to our clients and who do we really represent. The client, the concept of the client has changed. The client is no longer that person. In fact, the client is the planet, because if we don't serve that client, then we will have nothing left. So I think the days of the client saying, I want this, I want a copper roof because I want big aluminium, because I want this, because needs to be challenged. We no longer have that luxury. So the shift would be from this masonry steel RC technology to bio-based grown technologies. And why I say that, because this timber is the main one in South Africa, and I think there are others like bamboo or fluorine, and that could be used. So that's the big shift. So what are some of the things? How are we going to achieve this? How do we develop this? We already have a very small cottage industry timber culture in South Africa. There is some timber framing here and there. What's really the problem? And in my work with Brunt and with Ben is that South Africa could produce enough timber for a good portion or percentage for housing in South African buildings. But it's quite simply put down to the fact that we are a reinforced concrete and steel and brick culture. That's all. So when I speak to people, when I was here in Connecticut and I went to speak to contractors and I met them on site, I said, how do you guys feel about building a concrete or brick structure? And they had the same response as if you asked a brick builder here. They just don't know the material. All they know is timber. So we don't know that timber. There are some who know about timber who've made it a special interest, but the dedicated understanding of the material isn't there at all, like reinforced concrete or steel. So I know as an engineer, if you go to any engineer who's a reinforced concrete engineer, he or she will know everything on how to specify all the ins and outs. They'll know all the nuances and all the problems of concrete, and concrete has got the same percentage of problems as timber has, and so has steel. They all got their problems, just that those two industries have really worked a way around it on how to do it, and it's become accepted norm on how to handle those problems, and the skills are all there, the books are all there, the support's there. And interestingly enough is that if a reinforced concrete structure has a problem, if there's corrosion, if there's spalling, cracking, whatever, the same with steel, if the material shows early aging or degradation, and there's a case, it's usually the designer that is blamed or the contractor. But if timber fails in South Africa, it's never the designer or the contractor, it's usually the material is blamed. And that all that tells us is that the understanding of this material is limited in South Africa. It's not at the forefront. And we've got a chicken and egg situation. How do we promote the timber? How do we convince clients? And how do we get, what comes first, the demand from the industry or the skills from the designers and the contractors? So that has got stuck, and that requires some discussion. But hopefully with Stellenbosch now is trying to promote this and doing their courses to try and trigger that. But there is a big problem, is that at the moment, the architectural and engineering schools in South Africa aren't teaching sustainability. It's not there as a rigor from first year. And in engineers graduate with an understanding of concrete and steel. Timber isn't included. In fact, there's very little brickwork. And you'll find in South Africa, there's even a shortage in understanding of brickwork masonry, of designing structures with that. Because of those two gaps, it really comes out of the training of the technicons in the universities, and we really need a shift there. So what do we need? We need to mimic, in a way, the steel and concrete industry. We need, first of all, we need the right design skills. We need the right technical skills. We need the right training facilities. We need the right strategies for in design and applications. Use timber where timber is needed. We use timber where timber is appropriate. Don't try and force timber to do what steel does or what bricks do or what concrete does. Do it in a way timber does, as in that building has been designed for timber. And I see that there's quite a lot of problems. People will, for example, specify doors and windows from a local timber. It buckles, it doesn't work. They blame the timber, but they've tried to force it to do something that steel does or aluminium does. So that's inappropriate. And we need the right manufacturing processes to support us. So we've got to find a way of gearing this up. I'm hoping it can start with consultants, and because consultants, architects make early decisions in stage one, and if properly informed, stage one to convince clients that maybe that this is the way to go. There are distinct perceptions and myths around this material, which I'm just going to fly through quickly. The challenges of timber, of designing timber, are generally fire, water, and acoustics. Those are the three things. There's a perception around fire, which is largely incorrect. is that if you have a fire in a building, in fact, I'd rather be in a timber building than a steel building, because steel will fail before. And timber beams will char, and they'll take longer to burn. But the whole concept of not understanding around timber is that buildings, any fire, whether it's a brick structure, steel structure, concrete or timber, generally if you have a big fire, that building is gone, no matter what material it is. And it's not the material that burns, it's all what's on the inside, all the curtains, carpets, all the furniture and fittings, the paints, that's what burns and gets. So for example, you'll see a brick building with a steel truss system and it's down to the ground. So it's not that those materials are burning themselves, it's everything around it, and those materials can't handle those high temperatures. Water is an issue around timber, and that's maintaining and what timber doesn't do well in water. You treat it, but here again, the key is to design the environment for timber, which I'll come when I do some examples. And timber moves. So it's a living product, and that's the skill to design with it. As concrete has major problems, and as I imagine, there's just each material has its issues. The big advantages of timber, it's very light. So on average, a timber, if that building you're looking at there, if that had been done in brick and concrete, it would be 10 times heavier than a timber building. In fact, more than 10 times heavier. So what that means in terms of efficacy and efficiency, it means that if you design with a heavy building, the engineer's spending all the time designing to hold the self-weight of the building. So it's incredibly inefficient. It's directing all its energy, its structural energy, into holding itself up. The live loads are secondary. In timber building, it's the other way around. In fact, you anchor the building down because it's light, and all the structural energy is going just to carrying the live loads. So they're highly effective and very efficient in terms of structural efficacy. Given the light weight of these materials, they are easy and light to transport to get to site. So you've got a tenth of the weight of the material to bring to site. In fact, it is less than that, but I'm being generous. And it needs much lighter foundations, and it is absolutely superior in earthquakes. So whatever happened in Turkey, if that was a timber environment, there would be no problem, because these materials in terms of stability in earthquakes are infinitely better than heavy concrete buildings. So a little bit more then to pick up from Ben. Lots of doubt. I mean, many engineers and architects with lots of doubt around the material. How SA pine and how good is it? Well, it depends. There's lots of different types of SA pine, and it depends how it's been prepared, how it's been selected, how it's been treated. That all works. But I can tell you that and I'll show my examples, I have not really had a problem with SA pine. But the knowledge around how to select and treat and design it appropriately I would think, needs work. Eucalyptus, how good is it? And I'll show you the examples. I think we've got two fantastic materials here, and it's enough, I think, for us to do what we need to do. At all costs, I think, if you're going to use any imported timber, I would only use it probably from the northern forests where there are sustainable plantations, in the Baltic areas and Canada and areas like that, where they have massive, big natural forests, and they replant them. So they're in their natural environment, and they are managed sustainable natural forests, stroke plantation forests, where our South African ones are completely aliens, which have been managed and unbelievably well. But I think that we have excellent timber, and if we go into hybrids, we will have all that we need. I'm now just going to conclude with a few case studies. I just want to check how I'm doing for time. Yep. Is that in the 70s and 80s, there was a big push for timber in South Africa. This is Wit Sports Hall. And the industry started to make big inroads. And by the 80s, towards the end of the 80s, that fell away. I think I've tried to understand. I've been told that the lobby of the concrete and brick and steel closed that off. And also the perception of timber in South Africa is not good. So I'm just going to show a few case studies where I've tried different South African timbers to see what happens, and I've dared to do it. So I'd like to really speak from my experience. This is a pedestrian bridge in Newlands, and it was made from Clado Calyx. And that's the bridge about 10 years ago. It's 100% made from Clado Calyx, so that's a eucalypt. And on the right is what it looks like 10 years later. You can see it hasn't warped. We selected the timber carefully. That's part of the process. Designed the joints correctly, and that bridge has weathered well. Clado Calyx is a very hard and durable material. Untreated. You can't really treat eucalypt. This is a project in West Africa, and this was a challenge for me to the developers of the mine. Was I said that you could do all your industrial buildings fully out of timber. They agreed that I only go with the timber roofs, and this is timber roofs carrying heavy loads of generator exhausts and things like that. And this was built 10 years ago, and the latest visit by one of our team was that everything has just performed perfectly. There's no problem. And that, if you have a look at that steel section, that's what you'd compete with. If there was a fire, you can tell that that steel is not going to last long. These are the buildings. That facade there, the roof, all the timber that you see there is SA pine. And the internal shutters there are laminated pine product. So in the trick, I'll come back to windows, that timbers, SA pine's given a very bad press. What that was specified was we took grade 7, then we selected from grade 7. We let that timber sit for 2 or 3 months, and then we selected from that, but designed the windows informed by what SA pine can do and can't do. So there's can you see narrow sections, quite big sections with mullions to hold the thing together, continuous for moments, so that you get a good braced window. This is poplar trusses and flooring. I was the engineer for this, and this is by Keith Struthers. But poplar is a very small part of South African timber. This I advised on this. This is by Levico in Natal. This was all pine decking. And the art to pine decking here of SA pine is to use, this is tannerth treated, 33mm thick sections. That's on the left 10 years ago, and that's what it's aged to, a grey finish. Performed, you can see yourself, it has stayed in line. I think that's the #1 timber decking of choice. I'm really concerned about this continuous specifying of balau. I've been to those areas. There's no such thing as a balau plantation. An architect, us specifying balau is equivalent to a Japanese architect specifying rhino horn or ivory as inlays in their tables. It's the same. And I think that if you, off the list, I think it's safe that any timber from the tropics never specify it. Really, as ethically, it's just the wrong thing to do. This is a project in the Eastern Cape. This is Grandis. The Grandis was treated with boron. Now you can only treat the outer part of boron. You can't, it's too hard, the inner core of boron, a heart. That was treated boron. And the idea was, this is the chief's building, was to try and get it 100% carbon neutral. That was the challenge. So all those brick columns there are recycled brick. We did use a little bit of cement and lime. The walls are all made from the SA pine and a framework with, we used the African mix of mud and cow dung mix is for the walls. I'm not expecting anybody to go and do this, but to say the challenge was, how could we get it to as little low carbon as possible? Painted white for windows, and that's an idea we got. We think that in this one it really worked. The flooring, everything there's of timber or recycled bricks, SA pine windows again, and eucalyptus for the furniture. That was then the furniture was made from all the offcuts from the planking for the building. And again, doors and windows, SA pine doors and windows with eucalypt cladding. And just a built-in unit there with air vent circulations, all designed, passive cooling systems, passive lighting systems. This is my own office. This was an exercise in recycled bricks and recycled timber. And one of the challenges of timber is acoustics. And how to get around the acoustic problem is using double layer, ceiling layer, and that's off-cut underfelt, which gets dumped. So whenever you get your carpets cut, all the underfelt that's cut gets put into big containers and then dumped on our dump sites. And I just did an experiment there to see what could I pull from a dump site to use for sound insulation. The timber on the right is kerry gum, and it's a superb flooring. I got it from another project, recycled. So that kerry gum is 40 years old, and I'm sitting on it now, and it has performed well. On the top left, that timber is also recovered from a demolition project, and that was leadwood. And we got SA pine structure, double structure to accept the insulation. It's an example of some of the work I've seen around the world. This is when I worked in Indonesia. And here, what I really saw and understood from them, they build mainly with timber, and they design the environment so they do big overhangs, and they really work their structures to keep the sun and the rain and the wind and everything off their doors and windows and off their facades because of the timber facades. And then just to close off, there's a lot of hype around CLT. Just want to say at this point is that timber is a limited resource. We don't have unlimited amount of timber. And, I see some people doing single and double stories in CLT. It's an overkill. We don't want to overspecify. There's no reason to do single, double, even triple story out of CLT. That's a huge amount of timber. Balloon or platform frame is more than sufficient. I think there are sometimes to use this material. People are using it for floors. It is hopelessly inefficient as a suspended floor. The current system that we use in South Africa of beams and normal beams is much more efficient and effective. I think that it's been sexed up, and I think it's over so. It is, but maybe that's another workshop one day. Yes, it's a useful material in some instances, but it must be used carefully. There's a lot of things you can do with it. I think architects would get excited with this. And in concluding, I think that if we shift towards this, we've got the timber. We need to put pressure on the universities and the trainings to get timber as part, to get it up to equal to steel and concrete. And I commend Stellenbosch for taking this baton and in an attempt to try and make that contribution. I'm more interested to hear is, given your background, is to hear your comments and questions, because I'm sure there will be a lot that come up from this talk. Thanks, everybody.
Thank you, Vernon. Again, a fantastic and insightful presentation. Ben, you got some good comments from the attendees. Vernon, you're getting some virtual rounds of applause. There are a few questions on the chat. The one from John B says, what about plastic in a CO2, the plastic carbon dioxide per kilogram per ton?
So I think we must try to stay away from plastic as much as we possibly can, because, I mean, it's also a fossil-based resource. And the more we can specify grown products, as Vernon put it, timber, we're in a much better place than using anything that's fossil fuel-based.
Okay, thank you. Then we had a question from Bram, or actually it's got a Ken Levers. For Ben, it says, I missed the first 5 slides, so I may have missed the following. What about our indigenous trees suitable for construction and carpentry or joinery? Is there any significant move to convince farmers to in suitable areas to grow mahoganies, Bushman's tea, Cape chestnut? He's stunned to see the extent of indigenous tree plantations in Mozambique planted in the early to mid 20th century. Are we light years behind?
So yes, we can plant much more indigenous trees. And in many cases, we will do well with that, especially if we look at farmland that is in the drier areas. There we can plant avenues of trees, shelter belts, woodlots of indigenous trees, and we have vast areas of land where we can do this. Often we can then use these timbers as high value products. For example, think like something about kiat. the Pterocarpus angolensis. You know, a lot of these trees can be utilized. Red ivory. So a lot of these things we can plant, but we also have to keep in mind that their growth rate is much slower than our plantation forestry species. So we will also always need some commercially produced timber that is on specific specifications where we can, for example, use them as a roof truss or use them as a load-bearing member in a construction design. So that is where your pine and eucalyptus come in. So in the high rainfall areas, there's a case to be made for plantations of pine and eucalypt because it will form the fiber basket for our country still going forward. But in many specifically semi-arid areas where plantation forestry is not possible, there are many agroforestry options where you blend some trees in on the farm landscape rather than planting it wall to wall like in a plantation, but you plant an avenue of trees here or a windbreak there. There, specifically indigenous species can do very well.
Thank you, Ken. I hope that answers your question. We have a question from Brahm, also to Ben. 50% of all timber that is grown in South Africa is used for paper pulp. Can we use more of these timbers for construction, or can we use these species for mass timber construction?
Yes, certainly we can. And Brunt has been doing a lot of work on this, specifically around gluing and lamination of, for example, eucalyptus products, because it's basically the eucalyptus that we pulp in very, very large quantities in this country. We also export some eucalyptus chips that gets used for pulpwood to the Far East. So a lot of that timber can be channeled into structural timbers with the necessary gluing and lamination processes. And then one must remember that the half-life of this timber in terms of its carbon sequestration footprint becomes much longer, because paper products, somebody wraps a fish in it or somebody starts a braai fire in it or something like that, and it degrades a little bit more quickly. If it goes into a landfill, it has a moderately long life. But if it gets burnt up or used to decompose somewhere, it does not have a long half-life, whereas structural timber does have that. So I think there's a big place to shift towards more structural timber in our country, and we certainly have the resources to do that. If we get paid the right prices, it would not be necessary for people to export so much of our timber to go and become pulp and paper in the Far East. We can use it locally here in the construction industry.
Great, thank you. We also, I think, where was it, Derek? You asked a question around, does South Africa have real indigenous timber? I think we covered that. But then also you asked your opinion on poplar as a structural timber. I know, Vernon, you also covered that in your presentation. I don't know if you want to add to anything around the poplar as structural timber.
I can maybe start. Vernon, you can add on if you want, but I think the thing with poplar is it used to be grown in valley bottom positions, usually very close to wetlands. And in an attempt to become more environmentally sensitive, people have withdrawn these plantations, because when you plant a tree very close to a stream like that, it can use excessive amounts of water. And that's why they decided all of these riparian zones, we must take poplar out there and rather replace it with plantations on dry land positions in the landscape. In other words, stay further away from the stream to have that ecological corridor or ecological network that I showed you in my presentation. And that's the reason why poplar as a genus of trees has largely been diminished in our country and replaced with things like pine or eucalyptus rather. So those same areas will not be replanted again because of the sensitivity to plant trees close to riparian zones. Poplar is not such a good choice because it requires more wetness. And so you can do better with something like a eucalypt or a pine or even some indigenous tree.
Okay. While we're on the topic of the types of fiber, just Peter, I do see your question, but I'm going to come to Lisa Durrell. People are asking around bamboo and whether it should be grown in South Africa and the processing thereof and use. You know, how does this compare to standard timber?
I think if you go to the Far East, they found ways to use bamboo as a structural timber. But we've done one of the students did a master's on this, and there's a problem. It's useful maybe for flooring if you process it, but I think as a structural timber, it's not. And it's the same with poplar. Poplar is, I think, there's a small niche market because of its aesthetic value, but in terms of durability and performance, very hard to beat pine and eucalypt. Very, very difficult. In terms of reliability, working it, they are far superior to using bamboo or poplar as structural, architectural, or part of the building structure. So that's what I would advise. But bamboo for everything else, I think I can't answer that because I think leave it up to Ben.
I cannot really add much to the bamboo as a structural member to be used, so I sort of work with growing of the trees. I cannot really, maybe Brunt can help us there.
Brunt or Skulk, maybe we can hospital pass that one to you guys.
Yeah.
Sorry, I won't be able to help.
Yeah, sorry, not same here. I've used bamboo just in my house on a as a tabletop. It's actually quite a nice product, but in terms of the growing in SA and the impact it will have, I just don't know that. Sorry.
So you ask, what role do you see the ITC playing? I assume you mean the Institute of Timber Construction, playing in the promotion of structural use of timber. Roy, I've added you to our panel. Roy Southey is the Executive Director of Sawmilling South Africa. I was hoping I would find Eric from the ITC on the list here, but he isn't in the room. Roy, do you want to answer that question?
Yeah, thanks, Samantha. The ITC, like Sawmilling South Africa and Forestry South Africa, actively promote the increased use of timber, especially in the built environment. So the ITC, together with the rest of us, is doing tremendous work on promoting the further use of the increased use of timber. So that's happening.
Jean, you have a question around clients complaining about maintenance on timber. Any suggestions beyond varnish on which you can think of? Jean, I can refer you to the YouTube channel that I posted a link at the beginning of the session. We did a treatment of timber webinar last year, and we also we work quite closely with the South African Wood Preservers Association, so you would be able to get information from them. So hopefully that answers your question. And then we've got a question from 16939. Is there a list available indicating preferred usage in preferred construction elements such as structural, interior and exterior, or alternatively a list where certain timbers must be used? I've actually even posted the similar comments around whether or not we should have a green, yellow and red list like we do with fish around timber, and which timbers we should be using for which purpose.
I can just answer briefly. And that's all in the 10082. The different grading of timber and uses of timber is covered in SANS, at the appropriate SANS. And I think that's part of the training. I think that Stellenbosch is planning to do is to train on how to make those decisions. I just did want to answer the one on treatment. The decks that I showed you in Newlands and the one in Durban are not treated. In other words, you don't need to put varnish or oils on. Most of the time, most timbers, you don't need that if you've specified and designed it correctly.
Thank you very much. Thank you for that. Jay Pillay asks, can you comment on the use of stony pine in construction?
We don't have that much stone pine around in this country. Those are those umbrella-shaped pines that you find mostly here in the Western Cape. Two things about them: they produce edible nuts. It's the pine nut that you would put in a pesto if you were to make your own pesto. And so they are often more revered for their nut production than for their timber production. But when you do get to a point where the tree reaches the end of its life, they've got a very strong timber. You need almost hardwood equipment to saw the stone pine timber, but it is a very strong and very durable timber. So if you do have it available, go for it, but please don't cut it off before we've had our share of nuts from it, please.
I've used stone pine quite a bit. In Cape Town here, whenever these You can get it when it's available. There's Universal Timber used to have some. I could access it. When trees come down, it's very hard. You can't treat it. It's extremely durable. Use it for kitchen tops. It's a perfect timber for big kitchen tops.
Yes, Sam, I just wanted to mention exactly what Bram is mentioning now. A lot of the questions that's coming up is about wood as a material. And the guys in this course, you can go to, there's a website that we created. It's the address is thewoodapp.com. So you just put in thewoodapp.com, and then many of your questions that you have will be answered if you do some of the short courses on that website. I see that Sam, you put in the address there already. Thanks.
Thank you. Yes. Yeah, I think we've just skimming through the chat function. I see we're just checking that I've covered everybody and I haven't left anybody off. I think there is a lot of discussion around the bamboo. There are a few comments around the seismic design still to be developed for South Africa, and timber could dovetail with this. So that's, but we'll obviously pull an exported list of all of these questions. Minky, also you said that the craftsmen, the skills are needed for to match the growth in timber production and timber use in the built environment. And yeah, thank you, Gerard from FSC. He's put in a link around bamboo as a building material use. But I think we have, I think we've exhausted all the questions.
Yes, thank you, Samantha. So firstly, to all the attendees, thank you for attending this Talking Timber Sustainability of Timber in the Built Environment session that was sponsored by Sawmilling SA. Thank you for Roy Southey from Sawmilling SA with all the arrangements surrounding that. This specific timber session was also a collaboration between several parties, which includes the Department Trade of Industry and Competition, Stellenbosch University, University of Pretoria, and then Sawmilling South Africa. Then thank you very much to our speakers, Professor Ben du Toit and Professor Vernon Collis. I think it was very insightful. I personally learned a lot and enjoyed the sessions. I'm looking forward to future discussions as well. I believe the attendees also would like to have more discussions about these aspects. Then also a special thank you to the Fatwa Mea Zundu from the DTIC with driving the process. Then other people that I would like to mention is Samantha Charles from Frog Communications. Thank you very much. And then also Bram de Villiers from Earthworld Architects, which was in the back today. Thank you for assisting with the arranging the talks. And then Professor Brand Wessels from Stellenbosch University for attending and also giving insights. And then I think lastly for the Cape Institute for Architecture for arranging the CPD accreditation. Thank you very much.